Hey guys, we're going to talk about how to find rate of change and average rate of change for different types of functions. It used to be only used for linear functions, but now it's kind of seen and used for all types of functions. And the idea is the greater the rate of change, the steeper the line will look. Not longer, but steeper. So think of a roller coaster. If you think of a roller coaster, something that maybe like a little kid would go on, it would have like a little hill on it, as compared to like the Superman roller coaster, you have something really high. So like a line like this would have a greater rate of change than a line like this. It doesn't necessarily mean length of the line. So that's what we're going to focus on as we go through these notes. And they just want you to evaluate using the graph. Okay. It tells us the graph is used to the right, so there's nothing we can put in the calculator. For each of these values, you're looking on the x value. So like f of 0 is going to be 1, because you got this point down here. F of 4, 5, 6, 7, you get 7 for the answer, which would be this point right here. And they're kind of highlighting those points for us. For 7, it's 10. And then for 13, which is over here, we're going to have 15 as the corresponding y value. So they want us to find the change in the function over each of the following domain intervals. So they want us to subtract and show the change on the graph. So in this case, we're basically going upwards. So in the case of the first one, well, to get from 1 to 7, you're going up 6. And then from 4 to 7, you're going up 3 spaces. And then from 7 to 13, you're going up 1, 2, 3, 4, 5 spaces. So for part C, it says, why can't you compare the changes in f from part B to determine over which interval the function is changing the fastest? Well, again, when you're talking about rate of change, it's about the steepness. So you have to divide. In the case of B, we just counted the spaces up. We can say which one gained more value or got higher, but we can't say which one is the steepest until we compare and divide the y's by the x's. So it says that right here that this is the second greatest change, but as far as rate of change goes, this part right here, the second part, is actually going to be a little, in this case, this will be a little steeper than that part right there. So we're going to look at that in part D. So I'm going to go ahead and move this up a little bit. Now they want us to do 0 to 4. So we had 0, 1, and 4, 7. So we have changes, and pretty much you want to do, you can either do top minus bottom or bottom minus top. But either way you subtract, you're going vertical. So 0 minus 4 would be negative 4. 1 minus 7 would be negative 6. And then you would take the y value, negative 6, and divide it by the x value, negative 4. If you get a decimal, you can always change it back to a fraction. This is going to end up being 3 over 2. So that's my rate of change, which basically means for every 3 spaces I go up, I'm going over 2 spaces. If I look at the next one, we have 4, 7, and then we have 7, 10. Same thing, if I subtract the x's and y's, 4 minus 7 is negative 3, 7 minus 10 is negative 3, and then if I divide negative 3 by negative 3, I'm going to get 1. And in the case of this, well, this is not as steep as the 3 over 2. So what the 1 means is that for every space up, I go 1 over to the right. And then for the last part, we have 7, 10, and we had 13, 15. So I'm going For this, it's negative 6, 7 minus 13, and then negative 5 for this. And if you do negative 5 divided by negative 6, change it back to a fraction, you're going to end up with 5 over 6, which in that case, it's less than 1. So the part of this line that's the steepest would be the first part. This part right here, the one with the 3 over 2. That would be the greatest rate of change, because that would be equivalent to 1.5. And that's higher than 1. And then the 0.83, which we get from 5 over 6. So as we go ahead and you look at some of the examples, like on the back for exercise 2, when they give you the intervals for, let's say, negative 2 to 3, and they give you an equation like this one here, you're going to want to take this equation, go to y equals, and you want to look at the table. So you want to look at the table for those points. And really for this, you're going to have 2 points. You're going to have negative 2 in the y value, and then you'll have 3 in the y value. So you find these y values here and here by looking at the table for whatever function you're working on. Okay? So I'd like you to try this part, try to finish this part up on your own, and then if you are watching this video in class, call me over as soon as you get done with it, so I can check and make sure you did the work right. Okay? Otherwise, as you're working on the last 2 pages, you're going to work on each question, but also make sure you're showing the work like I did on the front page.